Today's lesson, we are going to recap all of the properties of our special quadrilaterals. For this lesson, please make sure that you have multiple colors to write with, as well as both of the sheets that have all of our examples going from 1 through 5. Let's go ahead and get started with example number 1. This is a quadrilateral chart that we have used throughout this unit. And what I would like to do is fill out all of our properties of quadrilaterals, starting at the very beginning, and then include in all of the other properties of kites as well as trapezoids. For this lesson, you might also want to have a straight edge to draw in your diagonals. So that might be something that you might need to pause the video and grab as well. So the first image at the very top of our chart is called a quadrilateral. A quadrilateral simply has 4 sides, and all angles add to 360 degrees. So every single one of these shapes that come below this quadrilateral has these properties. This is a quadrilateral. So all that's special about it is that it has 4 sides, and all of the angles add to 360. The first shape that we talked about was called a parallelogram. And a parallelogram has opposite sides that are parallel. As a result of opposite sides being parallel, what also ends up happening is that opposite sides are also congruent. Because of that, we will end up with opposite angles that are going to be congruent. So opposite angles will be congruent. In addition to those angles being congruent, those angles are also going to have a relationship with their next door neighbors. We call that next door neighbors say what's up. They are consecutive interior angles because these angles are created between parallel sides. So all of those angles are going to be supplementary. Next, I'm going to draw in the diagonals. And in a parallelogram, the diagonals are not congruent, but what they do is they bisect each other. So the diagonals are going to be different lengths, but what they do is they bisect each other. So at their point of intersection, we'll see that they will have that point of intersection will be the midpoint. So the diagonals are congruent, and that's about it. The diagonals are not congruent, they bisect each other. That's about it. They're not perpendicular. The diagonals are not congruent. The diagonals do not bisect anything. The only special thing that they have is that the diagonals bisect each other. And so those are all of our properties of a parallelogram. And beyond parallelogram are 3 special parallelograms, starting with this one over here, which is called a rectangle. And a rectangle is a parallelogram, so that means that opposite sides are parallel. That has something that's very special. And the thing that's special is that it has 4 right angles. So it's a parallelogram with 4 right angles. So as a result of this being a parallelogram with 4 right angles, there ends up being some special properties that come from it. First of all, in terms of those properties, the first thing that I have is that opposite sides are congruent. The only time when they are all congruent is if it's a square. So we'll talk about sometimes and always in just a minute. So opposite sides are congruent. The next thing I want you to note is that opposite angles are congruent. 90 and 90, they are equal to each other. 90 and 90, they are equal to each other. In addition to that, next door neighbors say what's up. 90 plus 90 is equal to 180. So consecutive interior angles are supplementary, going all the way around. Next, let's go ahead and mark up our diagonals. In a rectangle, the diagonals are going to be congruent to each other. In addition to that, they bisect each other just like a rectangle. I'm sorry, just like a parallelogram. But in a rectangle, they bisect each other and they are congruent. So in a parallelogram, diagonals bisect each other. In a rectangle, they also bisect each other and they are congruent. Notice my tick marks. All of them have 3 tick marks going all the way around. The diagonals are not perpendicular and they do not bisect opposite angles. So that is 2 properties that they do not have. But the extra property that they have from parallelograms or compared to parallelograms is that the diagonals are congruent, and that is a rectangle. The next shape that we have is a rhombus. And a rhombus is a parallelogram. So I'm going to mark up that it is a parallelogram. Opposite sides are parallel. It is a parallelogram. But what makes it special is that all sides are congruent. As a result, that means that other properties end up taking place. So one of those properties, because it's a parallelogram, so let me go ahead and connect it back to parallelogram, is that opposite angles are going to be congruent to each other. But unlike a rectangle, they're not going to be right angles. Sometimes they're right angles if it's a square, but not always. The next door neighbors do say what's up, going all the way around. So just like a parallelogram, we do have that. These are consecutive interior angles that are supplementary. And now let's talk about the diagonals. The diagonals of a rhombus are not congruent to each other. They are not congruent, but they do bisect each other just like a parallelogram. So when I do these marks, my marks are going to be that this has 2 tick marks, this has 2 tick marks, this has 3 tick marks, this has 3 tick marks. The diagonals are not congruent, but they do bisect each other. And the diagonals are perpendicular. So that is a right angle symbol going all the way around. In a rhombus. A rhombus has these triangles inside, and all of those triangles are 4 right triangles that are going to be congruent to each other. The next thing I want to make sure that I talk about is that the diagonals bisect the opposite angles. So I'm going to do these arrows to indicate that the diagonals bisect the opposite angles. So those angles have been bisected by the diagonals. So to recap, a rhombus has all of the properties of a parallelogram, but what makes it special is that all sides are congruent. As a result of all sides being congruent, the diagonals will end up being perpendicular and they bisect the opposite angles, in addition to bisecting each other. The things that rhombus does not have is rhombus does not have congruent diagonals like a rectangle does. So that is different. And all angles are not congruent like a rectangle. So that is another thing that's different. Now, rectangle and rhombus and parallelogram, all of those properties are connected to square, which is just below it. So this is a picture of a square. And in a square is a parallelogram. So I'm going to mark that up with arrows. It is a parallelogram. And because it's a parallelogram that is connected to rectangle and rhombus, it has all of those properties of a rectangle and a rhombus. For example, it has 4 right angles, just like a rectangle. And it has opposite sides that are congruent, but more specifically, all sides are congruent, like a rhombus. Opposite angles are, of course, congruent because 90 is equivalent to 90. A right angle is congruent to another right angle. Next door neighbors, do say what's up. These are called consecutive interior angles. And they do add to 180. 90 plus 90 is 180. Let's go ahead and draw in those diagonals. Just like the diagonals of a rectangle, the diagonals are going to be congruent. Just like the diagonals of a parallelogram, they will bisect each other. Just like the diagonals of a rhombus, they will intersect at a right angle and bisect the opposite angles. So let's go ahead and mark up all of those things. First of all, they are congruent to each other. So I am going to mark up with 2 tick marks that they are congruent. They do bisect each other, hence all of those tick marks are going to be the same. A square has diagonals that intersect at a right angle. So I'm just putting in those boxes, going all the way around, indicating that the square has right angles at the diagonals. The diagonals also bisect the opposite angles, and if all of the angles are from 90 degrees, half of 90 is 45, so all of these angles are 45 degrees. So the triangles inside that are created by the diagonals are going to be 4 congruent triangles, but more specifically, 4 congruent isosceles triangles. Now let's go ahead and talk about a kite. So another shape that's connected to quadrilateral that has no other shapes connected to it is a kite. So let's go ahead and write down kite. A kite has no parallel sides. Instead, it has 2 pairs of consecutive congruent sides. Those consecutive congruent sides touch each other. A kite has only 1 pair of congruent angles. The other pair of opposite angles that are not going to be congruent. So we have 1 pair of opposite angles that are congruent. The other opposite angles are not congruent. The opposite angles that are congruent are created by a long side meeting up with the short side. A long side meeting up with the short side. Let's go ahead and mark up the diagonals. The diagonals are not going to be congruent to each other. They do not bisect each other, but the long side does bisect the short diagonal. So the long diagonal does bisect the short diagonal. So I'm going to put in 3 tick marks. And it bisects that diagonal at a 90-degree angle. So the diagonals are perpendicular in a kite, and it does bisect one of the diagonals, but not both. And the diagonals are not congruent. So kite is a lot of 1. It has 1 pair of congruent angles. It has 1 diagonal that is bisected. And it has 1 pair of angles that are bisected. So the angles that are not congruent to each other, they are bisected by the long diagonal. The 2 angles that are congruent, they are not bisected. Typically, when it comes to kites, we use a lot of Pythagorean theorem. So I just want you to always keep in mind that you might be working with the Pythagorean theorem as well. All right, let's go ahead and talk about our last shape, which is all the way over on the other side, and that is called trapezoids. And a trapezoid is a very special quadrilateral. And what makes a trapezoid special is that it has only one pair of parallel sides, not two. Typically in a trapezoid, all side lengths are going to be a different measure. But because we have parallel sides, it has one pair of consecutive interior angles that are supplementary. And maybe I should have used orange for that. They are supplementary. Just one pair. These are called leg angles. And the leg angles, these two would be supplementary. And these two would be supplementary. Notice I'm using different arc marks for this trapezoid. None of the angles are related to each other than the leg angles. We have ourselves things that are called bases, and the base angles are not related to each other at all. Below it, we have an isosceles trapezoid. Because it is a trapezoid, that means that it has one pair of parallel sides. But this time, what makes it isosceles is that it has one pair of congruent sides, and those pairs are those sides are the legs. In addition to that, the base angles are going to be congruent to each other. And those leg angles are still going to be supplementary because it's in between two parallel sides. And so they are consecutive interior angles. The last thing about the diagonals, which I didn't mark up anything in the diagonals because there's no relationship of the diagonals in a trapezoid. But in an isosceles trapezoid, there is a relationship. And that relationship is that the diagonals, although they do not bisect each other, they are congruent to each other. So I'm going to try to mark up with like double tick marks. 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. Just to show that the diagonals do not bisect each other. They are not perpendicular. They do not bisect opposite angles, but the only thing that they do have is the diagonals are congruent to each other. So that is a recap of our entire chart. Please make sure you understand and study this chart so that it'll help you and as you are preparing for your next quiz or test. Let's go on to example number 2. In example number 2, we want to tell whether the statement is sometimes true, or is true or false. And in order for something to be true, it must always be true. So I guess let's go back to our chart really quick. Notice that we have connected shapes. As we are going down the chart, if I'm comparing like a parallelogram to a rectangle, like a parallelogram is sometimes a rectangle, or a parallelogram is sometimes a square. As you are looking at one shape compared to one that's below it, a trapezoid is sometimes an isosceles trapezoid. We call that going down the chart is sometimes. As you go down the chart. But as you go up the chart, a square is always a rhombus. A rectangle is always a parallelogram. An isosceles is always a trapezoid. A kite is always a quadrilateral. As you go up the chart, these are always statements. So I just want to make sure that I emphasize that. The never happens when there's a disconnect. A parallelogram will never be a trapezoid, and it will never be a kite. There is no connection. They will never be those. So now I think I'm ready to talk about example number 2. And these are talking about like different properties as well as if something is true for all. So the diagonals of a rectangle are perpendicular. And in this case, the answer is false. And that is because if this was instead a kite, a square, or a rhombus, then this would be a true statement. But a rectangle sometimes has perpendicular diagonals, but not always. So therefore, that answer is false. The diagonals of a rhombus are congruent. That is also false. The diagonals that are congruent, those shapes are an isosceles trapezoid, a rectangle, or a square. They have congruent diagonals. Isosceles trapezoid, a rectangle, or a square have congruent diagonals. One pair of opposite angles of a kite are congruent. That is true. It's where the short meets the long. Only one pair of opposite angles in a kite are congruent. That is true. The legs of a trapezoid are congruent. That is false. Instead, this needed to be isosceles trapezoid. The legs of an isosceles trapezoid are congruent. Next, we have if a quadrilateral is a rhombus, then it is a square. A rhombus is only sometimes a square because it's going down the chart. But if this was flip-flopped, then the answer would have been true. If a quadrilateral is a square, then it is a rhombus. If a quadrilateral is a rectangle, then it is a parallelogram. That is true. All rectangles are parallelograms. Every single one of them are. They have all of the properties of a parallelogram. If a quadrilateral is a parallelogram, then it is a trapezoid. There is no connection, so therefore that is a false statement. Let's go on to example number 3. In example number 3, we have STUV has at least, so that means at least means one or more pairs, at least one pair of consecutive sides that are congruent. What types of quadrilaterals meet this condition? So at least one pair means one or more pairs of consecutive sides that are congruent. So for sure, that's a kite. A kite has, if we were to draw a kite, which I've drawn better, so just forgive me. There we go. A kite has at least one pair of consecutive sides that are congruent. So this is one pair of consecutive sides. This is another pair. Certainly a kite meets these conditions. But let's think about what other shapes have next door neighbors that are congruent to each other in terms of side lengths. Well, a rhombus meets this criteria. And I want you to think about that. A rhombus has all sides that are congruent. So isn't it true that it has a pair of sides that touch that are congruent to each other? At least one pair. This has a total of 4 pairs that are congruent. So a rhombus certainly fits this criteria. And with that being said, you probably are saying, well, wouldn't a square work as well? And that is true. A square, if you think about what a square has, it also has all sides that are congruent. So therefore, the consecutive sides, it has at least one pair of consecutive sides that are congruent. Consecutive means that the sides touch each other. So the sides touch each other. Let's go ahead and talk about example number 4. Example number 4 says, what is the most specific name for the quadrilateral that you see here? So what I see in this is I see diagonals that are congruent. And so in a parallelogram, diagonals are not congruent. In a rhombus, diagonals are not congruent. In a square, they are congruent, and in a rectangle, they are congruent. So we have to make a decision about which one it is. Well, in a square, you would see a right angle at the diagonal. But I don't see that here. So there is no right angles. And so because there is no right angle symbol, that tells me it's not a square. Therefore, the most specific name that we can give this quadrilateral is a rectangle. All right, let's go ahead and look at example number 5. In example number 5, I'm giving you parallelogram, rectangle, rhombus, square, kite, trapezoid, isosceles trapezoid. And what we want to do is we want to look at each of these statements and we want to see which ones it describes. So in letter A, it says both pairs of opposite sides are parallel. So both pairs of opposite sides are parallel. So in a trapezoid, there's only one pair of opposite sides that are parallel. So that tells me it can't be trapezoid. Kite, no sides are parallel. So that tells me that this is a parallelogram and all of the parallelograms that are special. So a parallelogram, a rectangle, a rhombus, and a square. Letter B, both pairs of opposite angles. So both pairs of opposite angles are congruent. So this doesn't work with kite because kite only has one pair of opposite angles that are congruent. It doesn't work with trapezoids because trapezoids, it doesn't have any opposite angles that are congruent, just the base angles. So once again, this is a property of a parallelogram. So I'm going to write down parallelogram and all of the special parallelograms that we have. So parallelogram, rectangle, rhombus, and square. Letter C, it has exactly one pair of parallel sides. So the only shapes that has exactly one pair of parallel sides, that is a trapezoid and isosceles trapezoid. Letter D, it has no parallel sides, and that is a kite. A kite has no parallel sides. Letter E, the diagonals are perpendicular. So the diagonals are perpendicular in a kite and in a rhombus and in a square. The diagonals are congruent. So the diagonals are congruent in an isosceles trapezoid miss the S up here. And a rectangle and a square. The diagonals bisect at least one pair of opposite angles. So at least one pair means one pair or more. So I have that taking place in a kite. A kite has diagonals that bisect opposite angles. That also takes place in a rhombus. The opposite angles are bisected, and in a square. The diagonals bisect opposite angles. All angles are right angles. That takes place in two shapes, and those two shapes are rectangles and square. Letter I, all pairs of consecutive angles. So all pairs of consecutive angles are supplementary. So in a trapezoid, it only has one pair that are supplementary, but not all pairs. So therefore, isosceles trapezoids and trapezoids are out. Instead, this is a property of a parallelogram. So I'm going to write down a parallelogram and all of the special parallelograms. So parallelogram, rectangle, rhombus, and square. And finally, letter J. It has base angles that are congruent. The fact that they use the word base tells me that I'm not working with a parallelogram, because we don't have bases in parallelograms. So just base angles that are congruent, that's only one shape, and that's an isosceles trapezoid. And that is the end of today's lesson. If you have any questions over anything that I talked about in this lesson, please feel free to email me. Otherwise, I hope you have a wonderful day.